Hi guys, today we discuss the derivation of Z transform from the Laplace transform of any continuous signal. Let's have one continuous time domain signal, maybe like this, which is existing for positive values of t here, and the Laplace transform of this continuous time domain signal is also continuous, and but this kind of continuous signals cannot be processed through the digital systems. So in order to process any signal through the digital system, basically the nature of the signal must be discrete or digital. But whatever we acquire the signals from real world, all are in general continuous in nature. So there is the necessity to convert the analog signals to discrete signals. So how to convert these analog signals to discrete signals means by taking the samples from the existing continuous time domain signals, we can convert the analog to discrete or digital. There are two ways to take the samples from that. In general, we cannot catch the signal, we cannot plug the samples from that signal. So there must be some process to get the sampled version of the continuous signal. How to get that sample means the analog signal, which may be designated as x of t, may be multiplied with some impulse train which is defined from 0, 1, 2 up to infinite, whose area covered by this is 1. So when this continuous signal may be multiplied by this one, so that we can get the samples of these continuous signals. As just now we discussed, there are two types. One is non-uniform sampling and another one is uniform sampling. Non-uniform sampling means we may take one sample here and we may take some other sample here, or we may take sample very close to the previous one, and we may take the sample which is away from the previous one, like this. And this kind of non-uniform sampled version of analog signal may be transmitted through the digital system at the destination, or the output of the digital system is also digital in nature. But we cannot understand the language of zeros and ones. We means humans cannot understand. So again, at the destination, this digital signal must be converted back to analog again. With this non-uniform sampling, reconstruction of the analog signal or original signal is somehow difficult. So that's why, to avoid this kind of situation, better to have the uniform sampling, like the distance between two successive samples must be same. Let's say this is one sample is selected at a t equals to 0, and another one sample is at t, and the third sample is at 2t and 3t and so on up to infinite samples. That means the distance between these two samples is same, and the amount of that is capital T. And now this can be considered as xs of t. Xs of t means sampled version of x of t. Now this first sample can be represented as x of t into, this is delta of t, means impulse function, x of t into delta of t at where it is existing at t equals to 0, at t equals to 0, plus x of t into delta of t at t equals to capital T, and so on up to infinite terms we can write. So when we replace this t by 0, x of 0 into delta of t plus x of capital T into, at t equals to capital T, it will be considered as delta of t minus capital T, and this will be considered as delta of t minus 2t, means the shifted version of impulse function which is existing at t equals to 0. So this is called the train of impulse functions. So here it can be written as delta of t minus capital T and so on, like x of 2t into delta of t minus 2t and so on up to infinite times. Now we can summarize this, the sum of all these products, like sigma n equals to 0 to infinite x of n into capital T into delta of t minus nt. So for different values of n, we will get x of 0 into delta of t minus 0 into t means x of 0 into delta of t. If n is 1, x of 1 into capital T into delta of t minus capital T, and so on. For all possible values of n, we will get the same thing. And this is nothing but the sampled version of analog signal, xs of t. Now apply the Laplace transform on both sides, then we will get xs of s is equal to Laplace transform of this summation sigma n equals 0 to infinite x of n into capital T delta of t minus nt. Now when we can apply the Laplace transform means we can apply the Laplace transform to any function which is the function of small t, where small t is the independent variable t. Now x of n into capital T is not the function of time variable t, and here the impulse train is only the function of small t. So now we can rearrange this as sigma n equals to 0 to infinite x of nt into Laplace transform of delta of t minus nt. We know that the Laplace transform of impulse function delta of t is 1, but what is the Laplace transform of shifted version of impulse function? Based on the time shifting property of the Laplace transform, we can write this as sigma n equals to 0 to infinite x of n into capital T. This is 1 into e power minus the length of the shift, that is nt into s. Here in this case, the capital T value, that is the distance between two successive samples, is constant. As capital T is constant, x of nt can be summarized as xs of s is equal to sigma n equals to 0 to infinite x of n only, where n is the index or independent variable in the time domain and capital T is constant, so no need to write that one, into e power minus nts. Now as this is the summation, discrete summation, whereas the integration is the analog summation, as this is the discrete summation, to evaluate this value for all possible infinite values of n is difficult, as we have the exponential term here, and s is also having, s is nothing but s is equal to sigma plus j omega, where s is the independent variable in the frequency domain or in s domain, which is the complex in nature. That means it is having the real part as well as imaginary part. When we substitute s equals to sigma plus j omega here, that is somehow difficult to evaluate this one. By making some modifications or by considering some assumptions, we can convert this as, assume xs of s is equal to x of z and e power s into t is equal to z. Then we can write this as x of z is equal to sigma n equals to 0 to infinite x of n into z power minus n. So this is the z transform of discrete signal x of n, where z is also the independent variable in the frequency domain or in z plane, and this is also complex in nature. But here, instead of defining this z in the rectangular form, better to have z in polar form, like r into e power j theta, where r is the magnitude of z and theta is the angle of z.